Okay, this is Gubbi online classes for Ncert 10th standard and Cbse 10th standard. So today's session is problems on Thales theorem. So in the previous session we had solved problems on identity, that is identities and riders, maybe more riders on Thales theorem. So in today's session we will be going with still more number of problems on Thales theorem. Right. So on board I have a problem which is a rider. So before entering into riders, so let us recapitulate the things what we had learned in the previous classes. So if a line is drawn parallel to a side of a triangle, then it divides the other two sides proportionately. This is Thales theorem. If a line divides any two sides of a triangle proportionately, then it is parallel to the third side, that is the converse of BPT. So other two corollaries are in the mathematical forms, and third corollary, a statement can be given for that. If a line is drawn parallel to a side of a triangle, then the newly formed triangle, that is the sides of the newly formed triangle are proportional to the sides of the given triangle. This is corollary 3. So now, so we have 1, 2, 3, 4, 5 results. So these results, it's the knowledge. So when the problem is given, which knowledge has to be applied for the given data, that's the analysis. So that analysis comes to you when you observe your teacher solving problems on the board. Right. So listen to the conversation of the teacher, observe the steps what to be followed, and observe the discipline also what is to be followed, and how to conclude a problem. Right. So we'll go with the problem now. That is problem number 1. So in the figure, LM parallel to CB. So you can see this is the given figure here. So A, B, C, D is a quadrilateral. Maybe it's looking like a kite. Maybe anyway. So A, B, C, D is a quadrilateral. So in this LM parallel to CB, LM parallel to CB. So you can recognize triangle ABC here. So in triangle ABC, LM parallel to BC, and in triangle ADC here, LM parallel to CD. LN parallel to CD, right? So prove that AM by AB is equal to AN by AD, that is AM is to AB ratio is equal to AN is to AD ratio. We have to prove that. So similar to this problem, in the last session we had done it. So this is in the Ncert textbook problem. Let us go with this. So let us write the data for this, because as it is to prove that it's a rider, so rider has to be proved in the form of a theorem, right? So AM, LN parallel to CB, and LN parallel to CD, right? LN is one of my very close friend. Okay. So to prove that AM by AB is equal to AN by AD, right? We have to prove this. So no need of any constructions here, because data is sufficient to prove this. So let us get into proof. Okay, let us select a triangle. In triangle ABC, okay, LN parallel to BC, right? So now you are eligible to apply Thales theorem and its corollaries, not converse. Okay. So therefore, AM by AB, if it was AM by MB, it was Thales theorem. As I have taken AM by AB, it is the corollary of BPT. So AM by AB is equal to AL by AC, Take it as equation 1. So this is according to converse of BPT. You can write this. Converse of BPT as the reason. So let us go with the second triangle. In triangle ADC, LN parallel to DC, okay. So now AN by AD is equal to AL by AC, So take it as equation 2. So this is also according to converse of BPT. Very simple. Okay. So now look at both the equations. So here AM by AB, this one and AN by AD both are equal to the same thing, that is AN by AC and AN by AC. So if two things are equal to the same thing, they should be equal to one another, that is according to the axiom of geometry. So therefore from equations 1 and 2, equations 1 and 2, AM by AB will be equal to AN by AD. So hence we have proved the ratios are equal, right? So this is how we have to present this, very important. We'll go with the next problem. So in the figure DE parallel to AC, in the figure DE parallel to AC and DF parallel to AE, DF parallel to AE, okay, then prove that BF by FE, BF by FE is equal to BE by EC. BE by EC. Okay. So we've got the diagram. Like a little bit changes in the diagram. We'll change it. So this is the given diagram. So in the figure, DE parallel to AC, DE is parallel to AC, right? And then DF parallel to AE, DF parallel to AE, right? So prove that BF by FE, this one, BF by FE is equal to BE by EC, BE by EC. You have to prove that. Okay, we'll go with this. So let us write the data, very important. So DE parallel to AC. So if I write DE parallel to AC, you have to recognize the triangle here. So DE parallel to AC happens in triangle ABC. In triangle ABC, DE parallel to AC. Okay. Then DF parallel to AE. DF parallel to AE. So here DF is parallel to AE, you have to recognize the triangle. So it is triangle ABE. This is triangle ABE. So in two triangles, two parallel things are given. So you have to prove that. To prove that BF by FE, BF by FE is equal to BE by EC. BE by EC. Okay, let us get into the proof. So data is sufficient, no need of construction here. So now let us take the bigger triangle first. So BF by FE, that is BF by FE is equal to BE by EC, we have to prove it. So let us take the first triangle here. So in triangle ABC, big triangle I have taken. So in triangle ABC, DE parallel to AC, DE parallel to AC. Okay. So in triangle ABC, as DE is parallel to AC, BE by EC is equal to BD by AD. BD by AD. Take it as equation 1. So according to BPT. So this is direct BPT. Okay. So now let us take the second triangle. So in triangle ABE, in triangle ABE, okay, DF parallel to AE, DF parallel to AE. So therefore BF by FE, BF by FE is equal to BD by AD. BD by AD, take it as equation 2. So this is also according to BPT. So therefore, when we observe equations 1 and 2, BD by AD same thing exists in the RHS. So therefore, BE by EC is equal to BD by AD. BF by FE is also equal to BD by AD. So therefore, two things are equal to the same thing. Therefore, they should be equal to one another according to the axiom. So therefore, from equations 1 and 2, equations 1 and 2, BE by EC is equal to BF by FE. Hence it is proved. So it is a little bit important one. We have to observe very carefully the diagrams. We go to the next problem. So in the figure, DE parallel to OQ. Right. So this is the given diagram. Let's go with the figure DE parallel to OQ. So you can see here DE parallel to OQ. So DE parallel to OQ and DF parallel to QR. DF parallel to QR. So this DF is DF parallel to OR, DF parallel to OR, not QR, it is OR. Okay, then show that EF parallel to QR, EF parallel to QR, right. Okay, it's a very beautiful problem. It's based on corners of BPT. Right. So this is the given diagram, that is in triangle PQR, many things are happening inside it. So this is triangle POQ. In this triangle, ED is parallel to OQ, and in triangle POR, in this triangle, DF is parallel to OR. So using this data, you have to prove that in triangle PQR, EF is parallel to QR. So you have to prove that this line is parallel to this. So if you want to prove that this line is parallel to this, then we have to prove this line EF divides these two sides in the same ratio. So if a line divides any two sides of a triangle in the same ratio, then it is parallel to the third side, that is the converse of BPT. Okay, let us get into the data. So very important. ED parallel to OQ, that is DE. Okay, DE parallel to OQ and DF parallel to OR. Right, these are the things given to show that. So it is an identity. Show that problems are called identities. Prove that problems are called riders. Okay, to show that EF parallel to QR. EF parallel to QR. Right. So let us get into the proof. Right. So let us select the first triangle, that is triangle POQ. In triangle POQ. So in triangle POQ, ED parallel to OQ or DE parallel to OQ. Okay. So here in triangle POQ, DE is parallel to OQ, therefore PE by EQ will be equal to PD by OD. PD by OD. So take it as equation 1. It's according to, purely it is according to from BPT. Then come to the next triangle, in triangle POR. So in triangle POR, okay, PF by FR is equal to PD by OD. PD by, okay, let us do one thing which is parallel, or DF parallel to OR. Okay, sorry, DF parallel to OR. Okay. So now we will write the ratio. So PF by FR is equal to PD by OD. PD by OD. Take it as equation 2. So this is according to BPT. Right. So when you observe both the equations, P by EQ is equal to PD by OD. That is P by EQ is equal to PD by OD ratio. And PF by FR is also equal to PD by OD. So therefore, this ratio between these two is equal to this ratio. Ratio between these two is equal to this ratio means this ratio should be equal to this. So that is from equations 1 and 2. From equations 1 and 2. From equations 1 and 2, PE by EQ is equal to PF by FR. So this is done. So here line EF divides PQ, sides PQ, and another side is PR in the same ratio. So that is the line EF divides these two sides of triangle PQR in the same ratio. So therefore, according to the converse of BPT, that is, therefore, according to converse of BPT, EF should be parallel to QR. So hence it is proved. So here, clear thing is, if a line divides, this line divides the two sides of this triangle in the same ratio, that is proportionately. So hence according to the converse of BPT, this line should be parallel to this, that is the third side. If a line divides any two sides of a triangle proportionately, then it is parallel to the third side. So this is according to converse of BPT. Right. Very important problem. We'll go with the next problem. Using BPT, prove that a line drawn through the midpoint of midpoint of one side of a triangle parallel to another side bisects the third side. Okay. So using BPT we have to prove this. Neither we are going to use, that is BPT, purely BPT, or we can use its corollaries also, no doubt in that. So using BPT prove that a line drawn through the midpoint of one side of a triangle. So triangle in the sense I am going to draw a triangle here. That is the data and what I have read until now. That is the hypothesis part of the statement. A line drawn through the midpoint of a side of a triangle. So I will name the triangle as triangle ABC. A line drawn through the midpoint of side of a triangle. So I will select side AB. I will select the midpoint of side AB. I will call it as P. This line is drawn from the midpoint of midpoint. This is the midpoint, that is AP is equal to AB. Right? P is the midpoint of AB here. So that AP is equal to BP. From this point I am going to draw a line in such a way that that line becomes parallel to this side. So through the midpoint of one side of a triangle parallel to another. So I can draw this line parallel to this side. I cannot draw parallel to this side. So therefore I will draw a line from the midpoint of one side of a triangle parallel to another. So the line proceeds further and it bisects the third side. So this becomes the third side. So we have to prove that it meets at point Q, that is it meets AC at point Q. So we have to prove that this line, when drawn from the midpoint of one side of a triangle parallel to the other, it bisects the third side. That is, we have to prove that AQ is equal to QC, or we have to prove that Q is the midpoint of AC. Okay. So all things have to be done by using the BPT. We have to use BPT here. So in data, we are going to write the descriptions, what we have in the diagram. So in triangle ABC, okay, P is midpoint of AB. P is midpoint of AB, and AP is equal to BP. Since P is the midpoint, AP will be equal to BP, and PQ is parallel to BC. PQ is parallel to BC. So this is according to the data. So what is to be proved? So we have to prove that it bisects the third side. Means the line divides this line, the side AC, into two equal parts. So that we have to prove that AQ is equal to QC. We have to prove that AQ is equal to QC, or Q is midpoint of AC. So either that, either this, they come with the same meaning. Okay, no need of construction. Let us get into the proof. Okay, so it's very simple and a very interesting proof. So in triangle ABC, PQ is parallel to BC. PQ parallel to BC. That's given in the data. I have taken that. So if a line is drawn parallel to a side of a triangle, then it divides the other two sides proportionately. I am applying the Thales theorem. So as PQ is parallel to BC, AP by BP, that is AP by BP is equal to AQ by QC, So this is according to Thales theorem or BPT. Now, in the data also we have AP is equal to BP. So AP and BP gets cancelled here. So AP and BP gets cancelled. So therefore AQ by QC is equal to 1 because AP is equal to BP. This is the reason. So, if a fraction is equal to 1, then the numerator is equal to its denominator. So therefore, since AQ by QC is equal to 1, so, or in other words, you can go by cross multiplication. AQ into 1 is AQ, QC into 1 is QC. So therefore, AQ is equal to QC. So if AQ is equal to QC, therefore Q is midpoint of. So here you can see that AQ is equal to, it is QC. So Q becomes the midpoint of, Q is the midpoint of AC. So if Q becomes the midpoint of AC, therefore PQ bisects AC. So hence it is true. Right. So this is a very important writing. We'll go to the next problem. Using converse of BPT, this is very important. Using converse of BPT, you have to use converse of BPT. Prove that the line joining the midpoints of any two sides, joining the midpoints of any two sides, midpoints of any two sides of a triangle midpoints of two sides of a triangle is parallel to third side. Right. So this is the enunciation. Very important. Using converse of BPT, we have to do this. Prove that the line joining the midpoints of any two sides of a triangle is parallel to the third side. So in my mind, I got a triangle. So I am going to draw a triangle in the diagram. Very simple. Prove that the line joining the midpoints of any two sides of a triangle. So I am going to draw a triangle here. So I am going to name it by A, B and C. So triangle is ready. Prove that the line joining the midpoints of any two sides. So I will select these two sides, that is AB and AC. I will mark its midpoint. I will call it as P. I will mark it this midpoint. I will call it as Q. So that AP is equal to PB and AQ is equal to QC. I don't know whether it is AP is equal to AQ. I don't know that. I am not sure about it. But AP is equal to PB and AQ is equal to QC. Now, PQ is a line joining the midpoints of two sides of a triangle. So, prove that the line joining the midpoints of two sides of a triangle, this side and this side, two sides of a triangle, is parallel to the third side. So, we have to prove that PQ is parallel to BC. Right. So, we will go with the data. Very simple. So, in triangle ABC, P and Q are midpoints of AB and AC respectively, Okay, nice. AB and AC respectively. Then, so if P is the midpoint of AB, then AB is equal to PB. AP is equal to PB for my reference. I will write it down. I may use it in proof. AQ is equal to QC. AQ is equal to QC. Oh, correct. This is enough. So to prove that, so we have to prove that the line joining the midpoints of the two sides of a triangle is parallel to the third side. This is the third side. So I have to prove that PQ is parallel to BC. Okay. So PQ is parallel to BC. So to reach to this PQ parallel to BC, we have to take the help of converse of BPT. That is, you have to use the knowledge of converse of BPT. Okay. So we'll get into the proof. Okay, now in triangle ABC, P is the midpoint of AB, therefore AP is equal to PB. AP is equal to PB according to data. According to the data, therefore I wrote this. AP is equal to PB. Therefore, AP by PB is equal to 1. As these are equal to one another, when you divide AP by PB, we get 1. So therefore, AP is to PB is equal to 1:1. We can also write this, but not needed. Okay. AP by PB is 1. In the similar manner, AQ is equal to QC. AQ is equal to QC. This is according to the data. So therefore, AQ by QC is also equal to 1. Right? So now, as AP by PB is equal to 1, take it as equation 1. AQ by QC is equal to 1, take it as equation 2. From 1 and 2, AP by PB is equal to 1 and AQ by QC is also equal to 1. Therefore, two things are equal to the same ratio. That is 1 by 1 or 1:1. AQ by QC is equal to 1 by 1 and AP by PB is also equal to 1 by 1. So therefore, AP by PB is equal to AQ by AC. AQ by AC. So that means this line PQ is dividing these two sides of the triangle in the same ratio. The ratio is 1:1 in the same ratio. The line PQ divides the two sides of the triangle in the same ratio. I told you earlier that I don't know, this is to this I know, this is to this I know, but actually I do not know what about these two and what about these two. But now I have proved that they are same. So 1:1, 1:1. So this line divides this side in the ratio 1:1 and also this side in the ratio 1:1. Therefore, the line PQ divides the two sides of the triangle proportionately. So according to the converse of BPT, if a line divides any two sides of a triangle proportionately, then it is parallel to the third side. So AP by PB is equal to AQ by QC. Therefore, line PQ divides AB and AC proportionately. Right. So line PQ divides AB and AC proportionately or in the same ratio. So therefore, according to converse of BPT, PQ is parallel to BC. Hence it is true. Right. So this is how the proof is to be given. Right. So follow all the steps. Don't miss the things. Write the reason wherever required. Take equations 1 and 2. Compare them. Present in a very systematic manner. Just getting the answer at the last. I have done the entire problem. I have got the answer. See, most of the students go with this. I have done everything. I have solved all problems in the exam. I should get 100. See, these are the things what students speak, what I have heard. That's not the matter here. Reaching to the answer is not important. How you reach to the answer plays an important role. See, this is what we call discipline in geometry. Who has discipline in geometry will learn good geometry. So I hope you enjoyed the entire session today. These are all the 5 problems are very important. Practice them well so that next coming riders and entities are stronger than this. So you can apply your logic to learn them. So if you want to learn them better, you have to develop your logics here at small problems. So when you reach small targets in a very systematic manner, big targets can be easily achieved. So that's the thing. So I hope you will practice at home, stay safe and keep learning. Thank you all.